Hello students, today we will solve the question number 6 and the question goes like this. A molecule of substance has permanent dipole movement, electric dipole movement of magnitude 10 to the power minus 29 coulomb meter. A mole of substance is polarized at low temperature by applying a strong electrostatic field of magnitude 10 to the power 6 volt per meter. Direction of the field is suddenly changed by an angle of 60 degree. Estimate the heat released by the substance in aligning its dipole along the new direction of the field. For simplicity, assume 100% of polarization of the sample. So the question is telling us that we have a molecule, a particular molecule of A and B, which is having a dipole moment of 10 to the power minus 29 coulomb meter, and this A and B, one molecule is having this dipole moment. And how many molecules do we have? We have 1 mole of this substance, 1 mole of AB substance, okay, at low temperature. This 1 mole is polarized. At low temperature, this 1 mole is polarized, and we are assuming that this is 100% polarized. Polarized implies they get the polar effect, negative polarity and the positive polarity, which creates a little distance between them. The distance is del delta, not lambda, and that distance is important for making it a dipole. Dipoles are same charges of opposite polarity, which are differentiated or which have little difference of the distance between them, are separated by a little distance. Okay, now in this particular 1 mole of item, 1 mole of substance, we are introducing a external electric field, an external electric field of magnitude 10 to the power 6 volt per meter. When we are giving this external electric field, this is the strong one with a magnitude of 10 to the power 6, then after a little time what happened is that the direction of this AB dipole, is changed by an angle of 60 degree. Now after applying this sudden change, what we aim to find is the release of heat. At this particular point, it is in a stable point. Now it will release some energy to come to this 60 degree of angle. So what they aim to ask us is that we have to find the heat released in the form of work done in aligning its dipole to the direction of field, and that we have undergone. We are assuming it to be 100% polarized. 100% polarization implies that each and every molecule in 1 mole of substance is polarized. Each and every molecule in 1 mole of substance is polarized. That is 100% of polarization. In ideal situation, it is extremely tough for us to achieve that 100% polarized state of a substance. Now we will proceed to the solution. Electric dipole moment is 10 to the power minus 29 coulomb meter. Electrostatic field is 10 to the power 6 voltmeter. Change in angle is del theta 60 degree. Heat release in aligning the dipole alone alone E needed to be found out. Dipole of each molecule is 10 to the power minus 19 coulomb. In 1 mole of substance, we have 6 into 10 to the power 23 molecules, that is equals to Avogadro's number. Avogadro's number. Now the total dipole of all the molecules, why we are taking all? Because we are assuming it to be 100% polarized. It is dipole moment into number of molecules. Dipole moment is 10 to the power minus 29 into number of molecule is Na, that Na equals to 6 into 10 to the power 23. So answer we get is, this is the dipole moment for all the molecules, in 1 mole of substance, 6 into 10 to the power minus 6. Initial energy of dipole system when theta was 0 is given by U initial minus Pe cos theta, where value of P is 6 into 10 to the power minus 6. Electrostatic field is 10 to the power 6. Electrostatic field is same for theta equals to 0 and for theta equals to 60 degree into cos 0 degree. Cos 0 degree is 1. So as cos 0 degree is 1, this whole will get multiplied and the answer we will get is as minus 6 joule. Answer we will get it as minus 6 joules. Now final potential energy when theta is 0, at that time U final will be given as minus Pe cos theta degree. Again P is 6 into 10 to the power minus 6 into E is again 10 to the power 6, but cos theta is cos 60 degree. So what is the value of cos 60 degree? It is 1 by 2. From the trigonometry we got it is 1 by 2. So minus 6 into 1 by 2, answer is minus 3 joules. That is final potential energy. We got U initial and U final. Now we aim to find the change in potential energy when theta is changed from 0 degree to 60 degree. So the change will be given final minus initial. Final is 3, initial is minus 6. So this minus minus will turn to be plus and we will get plus 3 joules. Plus 3 joules. There is loss of potential energy about 3 joules. 3 joules of potential energy is lost while changing direction of dipole from 0 degree to 60 degree. Okay, this must be the energy released by the substance in the form of heat in aligning its dipole. So 3 joules of heat is released in aligning the dipole at 60 degrees. How do we find it out? Energy when released outside will be released as the another form of energy, and the another form of energy which we see most of the time is heat. That's why we concluded the loss of this particular loss of energy is converted to the heat, Okay, so in this question we have understood what is a dipole and how a dipole get affected by change in the angle by introduction of the electric field or any other external parameter. So in this case the external parameter was change in direction of our dipole, change in direction of our dipole. So dipole, when we see from the exam point view, it's very important. When we see it in the entrance examination, again it's very important, and when we see it study wise, it's important as well as the easiest and the interesting topic in the whole of electrostatics. So hope you will go through the notes provided for the electric dipole and understand the various relations and various formulas for this electrostatic dipole and the potential affecting this electrostatic dipole, how it changes from the axial point to the equatorial point. This is all you have to read. Then you have to understand. Here we have seen the change in potential energy. What does the change in potential energy in simple terms imply? It is the work done. Work done in making this dipole to 60 degree. Making this dipole to 60 degree. This work done is change in the final and the initial potential energies, and this work done, if it is minus, that is the work is done in doing so. When it is not minus, then it implies the work is done by the system. So system has done the work to make itself go from 0 to 60 degree, and whatever amount of energy difference is there from the initial and the final, that energy is converted into the heat. So that's all for today's class. Today's lecture will come up in the next class with a new topic. That's all for today. Have a good day. Bye bye.